Okay, so for lesson 6B, we're going to talk about distinguishable, non-distinguishable permutations and some combinations. And we'll talk about the combinations in a minute. So we're going to start right here in the middle of the note page. And in the word article, all the letters are different. So the number of ways that you could arrange them and make any type of word, nonsense or otherwise, is going to be 7 choices for the first blank, and 6 for the second, and 5 for the third, and all the way down. That's 5,040 ways. Now, what makes these things non-distinguishable is if the letters were to repeat. So think about this example right here, where in the word Mississippi, you have I's that repeat 4 times over, and you have 4 S's, and then on top of that you have 2 P's. So you've got a whole lot of letters that repeat throughout the course of this word. In order to figure out how many different ways you can arrange those letters, you have to divide out the ones that have like letters, because if you arrange the P's in any order, it's still going to look the same way. So in order to handle that, we're going to do what's called a non-distinguishable permutation. And the formula for that, you can see, is right down here. Now, it's kind of easy to do once you figure out what it is. The formula is as follows. Take the total number of items. So in the word Mississippi, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 11 letters total, and that's going to get you 11 factorial. And then what you will do is, for every letter that repeats, you'll count off how many times they repeat and divide by a factorial that matches that number. So for example, there are 4 I's, so I will divide by a 4 factorial for the I's. There are 4 S's, so I will divide by a 4 factorial for the S's also, and then there are 2 P's, so I will divide by a 2 factorial for the P's. Okay, so this might take a second for me to figure out. I'm going to grab a calculator here. And after putting this in the calculator, I'm going to end up with 34,650 ways to arrange the letters in the word Mississippi that are distinguishable. Okay? All right, let's take a look at another example here. We've got a situation where we have 10 seniors, 5 juniors, 5 sophomores, and 3 teachers that are on a committee. So by my count, that is 23 total. Okay, and this is going to continue on to the next page here. So for a photo, each subgroup is going to wear a different colored shirt. How many ways can they be lined up for the photo according to the color? Okay, well, we've got 23 total, and then you have to divide out by factorials that represent the different groups. So there are 10 seniors, 5 juniors, 5 sophomores, and 3 teachers. So let me grab a calculator and get that in there and tell you what that works out to be. Okay, so this number works out to be a really large one. Put the commas in the right place there. And you're looking at 82,455,124,752. Big number, the number of ways that they can be lined up for a photo according to color. That's quite a bit. Okay, now the word Tennessee, let's count off the number of letters in that first. That would help. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So this one's going to be a little bit more tame. And then we look for the letters that repeat. So let's start with the E's. I see 4 of those. And then for the N's, I see just 2 of those. And then there's a couple of S's that repeat that you can see right there. So that'll be a 2 factorial. This one might be a little bit easier to do by hand. 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay, and then down here, we've got a 4, a 3, a 2, and a 1. And then a 2 and a 1. And then a 2 and a 1. All right, let's see what we can get to cancel here. Well, I like getting rid of that 4, 3, 2, 1. And I'm pretty sure we can get rid of the 2's and make that a 2. So let's see, we've got 9 times 2 times 7 times 6 times 5. So 9 times 2 times 7 times 6 times 5, and that works out to be 3,780 for our answer there. Okay? All right, so a lot of time spent yesterday was on permutations, and today we're going to spend a little bit of time on combinations. And the big difference between combinations and permutations is with combinations, order does not matter. The order in which you pick things is not important. So the way that you can tell between the two is you have permutations in which you have some kind of arrangement or some kind of order that's important, like a batting lineup in a baseball game, or maybe you're concerned about people doing specific jobs. If I'm just selecting a committee of people, that's a little bit different then. And I could once again tell you to go to the crazy formula and try to memorize this thing, but those of you who were paying close attention yesterday know if you go to the math and then slide over to the prob menu, you will discover that you'll have this option somewhere on your screen, and you can select that in lieu of doing the formula. Okay? So if I wanted to pick 4 of 25 students for doing a survey, they're all doing the survey, so it really doesn't matter the order in which these things happen. I can pick the survey of recipients by taking a combination of 25 things taken 4 at a time. So you can see it's just like permutations, except we've got no order mattering here. So I've got 25 on top, and then I have 25 minus 4 factorial on the bottom, and then your r factorial, which is also 4. So if I simplify this a little bit, I'm going to end up with 25 times 24 times 23 times 22, and then everything 21 and below will cancel with this guy right here. And then I'm going to have 4 times 3 times 2 times 1. Now, strangely enough, that all multiplies to 24. So you can cancel it out with the 24, and then you get 25 times 23 times 22 as your answer, which is 12,650. So there's your answer on that one. All right, let's run through the rest of the quick examples here. If I've got 5 math books and I want to choose 3 of them for my next set of notes, well, it doesn't matter the order in which I pick them. It might matter the order in which I use them, but just to select them for this part, order really doesn't matter. So I have the number of combinations of 5 things taken 3 at a time, and you're going to discover very quickly what this works out to be. And I'm going to have to do a little quick math in my head here. It's going to be 5 factorial and 2 factorial and 3 factorial. So we're going to have 5 times 4 up top and 2 times 1 on the bottom when things cancel out. And there's 10 different ways I can select a group of 3. Okay. All right, down here to example C real quick. If a salesman has 10 clients in Clive, how many ways can he select exactly 3 clients to visit? Well, the order of which doesn't matter. I mean, it might matter for your expense report a little bit later, but ultimately right now it really doesn't matter. So this would be combinations of 10 things taken 3 at a time. And if you want to get that out of your calculator, it's not hard to do. And you'll end up with 120 different ways that the salesman can select 3 clients out of 10 to visit. Okay? Now, I've got some bad news here for this next one. We have the dreaded words "at least" in the next problem. In how many ways can the salesman select at least 8 of the 10 accounts? Well, that means if it's at least 8 of the 10, he can choose 8, choose 9, or choose all 10. And if that's the situation, you've got to count each one of them separately and then add them together. So when you see the words "at least" or "at most" or something to that effect, you've got to think that you've got several cases to count out and then add them all together. So I've got the combinations of 10 things taken 8 at a time, and the combinations of 10 things taken 9 at a time, and the combinations of 10 things taken all 10 at a time. All right, now by the way, there's only one way to do that, and that's to take all of them. There's 10 ways to choose 9 items, and that's to leave each one out once. And 10 choose 8 is a number that I'm going to need to reach for the calculator for. And that's going to end up being 45. So I have 56 ways that I can select at least 8 of the 10 for a report. All right, not too bad to do. Okay, and then for this last page right here, what I'm going to do is just make it pretty easy. I'm going to determine if it is a permutation or a combination, and then I'll do the setup and I'll let you figure out what the actual number is on your own with the calculator. And we'll get those results posted pretty soon in class. Okay, so if we have a 4-digit passcode and no numbers are to be repeated, well, I'm going to call this a permutation, and the reason why is because, as we've talked about in class, with a passcode, order does indeed matter. The passcode 1234 is different from the passcode 4321. So, since order matters, there are 10 possible digits, and I can take 4 of them. Okay. So for part B, it says a light bulb manufacturer selects 3 bulbs from a box of 15 for testing. How many ways can the bulbs be selected? Okay, so the secret word here in this case is selection. And if you're just choosing without any bit of order that has to go along with it, then you're going to look for a C. That's a combination. So in this case, it would be 15, choose 3. And again, we'll let you figure out what that one is. Let me clean this up a little here. Okay. All right. High school basketball conference contains 8 teams. How many games must be played so that each team plays each other exactly once? This is a quintessential quiz bowl problem, actually, for me when I direct tournaments. So what I do is I have the number of combinations of 8 teams taken 2 at a time. Combinations are, the order doesn't matter. Johnston playing Waukee is the same thing as Waukee playing Johnston. Okay. Now, the last two are kind of interesting because it says, how many ways can a manager select? Okay, so once again, there's that magic word select, and that's going to signal that we're interested in a combination here, choosing 4 of the 12 for a promotion. All right, now for the last one we have here, it's going to be, how many ways can a manager select 4 of his 12 employees to each complete a different job? Well, now that's a little bit different because if they're completing different jobs, then that's something that I'm going to have to think about in terms of maybe me doing one specific job is different than me doing something else. So this would be a permutation of 12 things taken 4 at a time. Okay? All right, and down here at the bottom of the page, you're going to see some cue words here for permutations like arrangement, schedule, order. However, if you're going to do a combination, you might look for a group or committee or a set or a sample. Or again, I'd go back to select. If you're just choosing them, then it's just going to be a combination. Okay, there's the information for this particular section, and we'll see you in class.